Hi, and welcome to my video on the horizontal reflection in the y-axis of an ordered pair. Horizontal reflection is, by me, is denoted by HR, horizontal reflection. A horizontal reflection is a reflection of an ordered pair in the y-axis. When you're horizontally, you reflect in the y, going sideways. You change x to negative x in a mapping rule reflects any point in the y-axis. Changing x to negative x reflects a point in the y-axis. Notice you're changing the opposite coordinates. So that's in the y-axis, you're changing the x to negative x. The mapping rule for reflecting in the y-axis is x comma y map to negative x comma y. So when you reflect in the y-axis, you're changing the x but not the y's. Let's do some examples. Reflect each in the y-axis. Let's take the point 2, 3. X is 2, y is 3, right there. And reflect in the y-axis, you move over here. So that's 3 to the right. 2 to the right. So now we go 2 to the left. So this point is negative 2, 3. Because remember, you're going negative x comma y. So the opposite of x, keeping the y. And the point negative 3, negative 1. So the point is x is negative 3, y is negative 1, which is right here. And reflecting in the y-axis, so that's 3 on the left. So we go 3 on the right, we reflect in the y-axis, goes to here. So that point is 3, negative 1. And again, the reflection in the y-axis is negative x, y. So it's the negative of negative 3, which is 3, and you do not change the y. Okay, find the image of each and graph both ordered pairs using the mapping rule x comma y map to negative x, y. So negative x, changing the x to negative x means reflecting in the y-axis. So we have the point negative 1, 2. So x is negative 1. Y is 2, which is there. So we reflect in the y-axis. That's 2, 1 to the left. So we go 1 to the right, right there. So that's x is 1, y is 2. And again, that's negative x comma y. So it's the opposite of negative 1, which is 1, and you don't change the y. 3, negative 1. And again, just look at the reflection in the y-axis. It's negative x, y. 3, the negative of 3 is negative 3, and you don't change the y. Let's graph it to see. 3, negative 1, x is 3, y is negative 1 right there. So when you reflect in the y, you go this way, right there. So that's 3 to the right. This is 3 to the left. So this ordered pair is negative 3, negative 1. And again, number 3, if you reflect in the y-axis, then you're doing negative x comma y. So the negative of a negative 2 is 2, and you don't change the y, so it's negative 4. So let's plot the point negative 2, negative 4. X is negative 2, y is negative 4, right there. And reflect in the y-axis means that's 2 to the left, so you go 2 to the right. So there it is. So x is 2, y is negative 4. Reflecting in the y-axis. The mapping rule. The mapping rule for reflecting in the y-axis, x comma y goes to negative x, y. Reflecting in the y-axis changes the x, not the y. And to do a further explanation on that, I made up a little grid to show you what's happening here. And let me illustrate that. Turn this back. Let's take this grid now, and let's reflect each of these points on the right into the y-axis. So if we take A and reflect it in the y-axis, it goes across here. and it goes to right there. So watch. So A is being reflected, so I'm going to turn the page over. Reflect A in the y-axis. So right here, it goes to right there. And that is A prime as its image, and the coordinates is -2, 3. Notice you're changing the x to the opposite, but not the y. B is 4, -1. And when you reflect in the y-axis, okay, let me roll that back now. And let's reflect the B. So there's the B, 4, -1. So I'm going to reflect in the y-axis horizontally. There it goes. And when it does, it moves to right here. That's 4 units to the right. So this becomes 4 units to the left right there. So that's B prime. Like that. So it's a -4, -1. -4. Make my pen right here. -4, -1. And notice the y is plus on this side, is y minus on this side. Sorry, the x is plus on this side, minus on this side, and the y didn't change. C, let's go back again. C is 5, 6, and when you reflect in the y, 5, 6 moves over here. Here we go. Reflected. 5, 6. So 5, 6 moves. That's 5 units to the right. So we go 5 units to the left, which is right there. So that's C prime. And the coordinates of this one is -5, 6. Again, you change the y to you change the x. When you reflect in the y, you change the x coordinate to the opposite and keep the y as it is. Okay. CD is next. D is 6, 0. So let's take 6, 0 and reflect it in the y. Here we go. So 6, 0 is 6 on the right. So we move it on the left. 1, 2, 3, 4, 5, 6. Right there. So that's D. So we make the image D prime. And the coordinates of this point is -6, 0. And you can see 1, 2, 3, 4, 5, 6, -6, 0. And we have E, which is here. Reflect E in the y-axis. Go horizontally. So here we go. If we reflect, then E7, -4 becomes right here. That's E prime. So 7 becomes -7. -7. And y is -4. Again, you change the x coordinate to its opposite. So if you reflect this point, that's E prime. So if you took this point here and reflected in the y-axis, the -7 would become a 7, and the y would stay at the -4. So don't make it reflect left or right. When you reflect in the y, reflecting in the y-axis, the x becomes -x, and the y stays as it is. So reflecting in the y-axis, you change the x to its opposite, and you do not change the y. If you like my video, click on the like button, subscribe button, and notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.